this is first order differential equation. Unfortunately, it's not the linear. It is non-linear, right? But it is autonomous because you can find just dependent variable on your right-hand side, right? There is no theta, right? Then the first step for the phase line portrait, you have to start from finding equilibrium solution or the critical number. How can you do it? The definition is for autonomous, dy dt is equal to 0. So we can say y minus 2 times y minus 6 equals 0. Then you can easily find your equilibrium solution is 2 and 6. That's it, right? Once you find your equilibrium solution, I would like to ask you to draw the phase line portrait, right? So what is that? It's really simple, right? Just simply number line as we did in calculus 1 and just pointing your critical numbers. And then, as you can see here, there are 3 sections, right? And we're going to check your sign of dy over dt for each section. And as we did before, you can plug in any number in each section because all those numbers in same section will give you same sign of dy dt. That is the an idea, okay? So here we go. Let's talk about the first section, which is less than 2. Maybe we can try to plug in -10 or 0 or 1 or even 1.9, whatever you want. Okay, let me plug in, like for the practice, let's try to plug in 0. 0 minus 2, I'm talking y equals 0, okay? 0 minus 2 is -2, and 0 minus 6 is negative, right? So which means negative number times negative number is positive. So we can say positive, okay? Then as you talked about it, we're going to draw the arrow to the right. Is it okay? Then between 2 to 6, maybe 3 or 4, okay? 3 minus 2 is positive, but 3 minus 6 is negative. One positive number times one negative number is negative. So in the middle section, between 2 to 6 is dy dt negative that we can draw like this way. Is that okay? Then whenever you have y value bigger than 6, for example, 100. 100 minus 2, positive. 100 minus 6, positive. So we can say this section positive, then to the right. That's it. This is the phase line portrait, okay? Then once you have this one, we can easily find your equilibrium solutions are stable or unstable. What about 2? Coming, right? Which means it is stable. 2 is stable. And what about 6? Go away, which means unstable. So what I can say is your equilibrium solution 2 is stable solution and 6 is unstable solution, okay? And we are not supposed to stop here because in the exam, I'm gonna ask you to do the analysis, okay? Let me show it to you, okay? So first of all, think about any y value which is less than 2, okay? If it is your value, then that solution will getting close to 2, right? Okay, and keep that in your mind, okay? And when your y is equal to exactly 2, since it is equilibrium, which means dy dt equals 0, which means there is no change. So if y is 2 and it is always 2, right? And less than 2 and y is 2, same thing, right? But even you have bigger than 2, but still less than 6. I'm talking about between 2 and 6. Any y value which is in between 2 and 6 also going down and converts to the 2 as well, right? So we can combine all these things, less than 2, at 2, and between 2 and 6, right? So I can say like this way. Therefore, if your y value is less than 6, the limit t goes to infinite. I'm talking about your solution curve. 2 goes to the equilibrium solution to the horizontal line. Is it okay? And what about at 6? We have talked about every single point of y, okay? When y equals 6, that is equilibrium solution, which means your dy dt is equal to 0, which means there is no change. Rate of change equal to 0, right? So that's why there's no change. It is always 6. Then what about any y value which is bigger than 6? whenever your y value is bigger than 6, it is tempting to going up, right? So that's why your solution for the case y is bigger than 6 is plus infinite. Does it make sense? So these are the analysis for the solution from the phase line, okay? Let me try to show you like a real solution curve of this, okay? You can try to do the, like, what is it? The direction field plotter, and you can find everything here. But like if you want me to show you, and it looks like T and Y, and we found there are two equilibrium solution, right? And as I said, your vertical line is the phase line, right? So as we did like already the analysis, increasing, decreasing between 2 to 6, and increasing, right? Then your solution looks like this. Whenever you choose any value which is less than 2, then it's tempting to converge like this way, any number. You understand, right? And between 2 to 6, it's going down like this way, and something like that, right? So if you choose like, any value which is bigger than 6, that will happen like this way, away, okay? So these blue lines are the not exact solution for this one, but like, it's kind of like this kind of shape, okay? Above 6 is like blow up, but between 2 to 6 or like less than 6, all of them is try to convert, getting close to the like, equilibrium solution y equal 2, because that is stable, okay?